Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now going to be going through question number 3 from the June 2019 International A-Level Edexcel S1 Statistics S1 paper. This question is about probability. It tells us about a certain disease that occurs in a population in two mutually exclusive types. It is difficult to diagnose people with type A of the disease, and there is an unknown proportion P of the population with type A. It is easier to diagnose people with type B of the disease, and it is known that 2% of the population have type B. Okay, so now there's an important word here, which is mutually exclusive. And what that means in this particular context here is that somebody who has type A of the disease will not have type B, and vice versa. So either they have type A or they have type B. They cannot have, both. They're mutually exclusive. All right. So that's one thing. So if they have type A, that means they can't have type B. If they have type B, that means they can't have type A. That's what that means in this context. All right. Then it says a test has been developed to help diagnose whether or not a person has the disease. The event T represents a positive test result or a positive result on the test. After a large-scale trial of the test, the following information was obtained. For a person with type B of the disease, the probability of a positive test result is 0.96. For a person who does not have the disease, the probability of a positive test is 0.05. And for a person with type A of the disease, the probability of a positive test is Q, which we don't know. So we don't know the proportion or probability of somebody with type A of, how many people have type A of the disease. There's an unknown proportion there. That's P. That's unknown. And we also don't know the probability of a positive test result for type A, and they've called that Q. So we got to complete this diagram here, this tree diagram, with the information that we just took here. So in this tree diagram, we know that type A, probability is P, as I mentioned. Type B, they told us the probability of having type B is, where is it? Okay, it's known that 2% of the population have type B. Okay, so the probability of having type B of the disease is 2%, which is 0.02. And the probability of having no disease obviously then will be 1 minus these two probabilities added together. So you're going to have 1 take away P plus 0.02. So you're going to end up with minus 1 minus P, and it's going to be 1 minus 0.00. So have 1 minus P minus 0.02. So you end up with 0.98. 1 minus 0.02 is 0.98. So 0.98 minus P. That's 0.98 take away P. That's the probability of having no disease. It's these all add up to 1. And the probability of having type A disease and having a negative test result is going to be 1 minus Q, and the probability of having a positive test result if you've got type B is 0.96. So this is 0.96 and this is 0.04, and it says the probability of having a positive test result when you don't have the disease is 0.05. So that's positive and no disease. Therefore this is 0.95, because each of these separate branches add up to 1. Now just a little I'll explain that in the next section. So we've got this table set up now. Now we're going to use the table to answer some of the questions here, and we'll sort that out. Okay, so it says the probability of a randomly selected person having a positive test result is 0.169. Okay, so that means the probability of somebody having a positive test result is 0.169. And for a person with a positive test result, the probability that they do not have the disease is 41 over 169. So there's a conditional probability here. So it says we know the person has a positive test result, and the probability that they do not have the disease given that, so basically the probability that they don't have the disease given that they have a positive test result is 41 over 169. So that's the information that's given to us in this part of the question. Now, so let's look at these outcomes first and write them down. So here we have the outcome that somebody has type A and they have a positive test result. And this is the probability, the outcome, this outcome here is the outcome that somebody has type A of the disease, but they have a negative test result. Okay, so this is actually something which will be, something which is misleading for the patient, because they will think they don't have the disease, but they actually have it. That's what this is. This is like an error, you could say, in the test. The test should, if you have type A, the test should show that they have type A, which is this one here. But if they have type A and the test shows they don't have type A, they will go away thinking they don't have the disease, but they actually do have it, which is, not a good situation. So this tests, of course, have errors. So this is the probability that they have type B and they got a positive test result, so they know they've got it and they can then, do something about it. But this is where they have type B disease, but they got a negative test result, which is, again, similar to that situation. Not very good, because they will think they don't have it, but they do have it, and they might not to take any steps to cure it. And this is the probability that they have no disease, but they get a positive test result, which is also not good, because they think they have the disease and they don't actually have it, so they might go through some unnecessary treatment. And this is a probability that they don't have the disease and they have a negative test result, which is, the right thing. This is the good thing here, because they don't have the disease, they get negative test result, they won't take any unnecessary treatments or whatever. So these are the outcomes of all of these probabilities. Now, the probability of each of these outcomes is found by multiplying along the branches. So the probability of this outcome is P times Q. And the probability of this outcome is P times 1 minus Q. Okay, P times 1 minus Q. That's the probability of that outcome. The probability of this outcome is 0.02 times 0.96 times 0.96. And this outcome is 0.02 times 0.04. And for this outcome, you're going to have 0.98 minus P multiplied by 0.05. And for this outcome, you have 0.98 minus P multiplied by 0.95. So these are the probabilities of each of these outcomes. We can calculate some of them when we need them. Now, let's have a look at the situation. We've got to find the values of P and Q using the information that they gave us. That the probability of having a positive test result is 0.169. Now, the probability of having a positive test result includes all the outcomes where you have T and not T complement. So this is one of the outcomes, and this is another outcome, and this is another outcome. So these three outcomes together, added together, will give us 0.169. So that's how we can form an equation from that. So I can say that P times Q plus, we're going to have 0.02 times 0.96 plus, you're going to have 0.98 minus P times 0.05. That's going to give you 0.169. Okay, so that's how we can use that. We can now try to simplify some of these. So this gives us 0.02 times 0.96. That gives us 0.0192. Okay, I'll put that here as well. That's 0.0192. Okay, so you have PQ plus 0.0192 plus, and you're going to have to multiply these two. So you have 0.98 multiplied by 0.05, come on, 0.05. That gives you 0.049. Okay, so that's 0.049. 0.049, and that's going to give you minus 0.05p. So that's what that gives you. So you're going to have 0.049 minus 0.05p is equal to 0.169. So we can say that's one equation that we formed. Okay, I can simplify that later on if I need to. So that's one equation we formed from the information that the probability of getting a positive test result is 0.169. Then we have the probability, as you mentioned, as it says here, for a person with a positive test result, the probability that they do not have the disease is what, 41 over 169. So the probability that they don't have the disease, given that they have a positive test result, which is written in this form, is 41 over 169. So the probability that they don't have the disease, given that they've got a positive test result, is 41 over 169. So now, how do we understand what this means? Well, we can just think about the formula that we know, that when you have the probability of something given something else, you find the intersections and divide by what comes after given. Okay, because this is our sample set. So how do we understand that in this case? Well, here our sample set are all the positive test results, because we know they have a positive test result, given that they have a positive test result. So we're going to take all the outcomes. We're going to limit our sample space to only the positive test results, which is these three together, which we know is 0.169. So we can say that our sample space is the probability of having a positive test result, which we know already is 0.169. So we know the denominator. We're only looking at the outcomes which involve a positive test result. And we want to find from those which one is going to be where they don't have the disease. Well, the only place where they don't have the disease out of these outcomes is the one over here. So we know it's going to be this divided by, okay, the sum of all these three. So basically what we need to do is that's basically given by, as we mentioned, the intersection between D complement and T. This outcome, okay, which is this times that, okay, divided by all the outcomes which have a T in it, not T complement, T, which is these three together, which they've told us is 0.169. So what is the outcome here? Well, it's 0.049 minus 0.05p. That's this outcome here. So you have, this is equal to 0.049 take away 0.05p, okay, divided by the probability that they have a positive test result, which we know is 0.169. Okay, and we know that this is equal to 41 over 169. So what I can actually do is just write this underneath here. That's better. I know that this is equal to 41 over 169. So this is equal to 41 over 169. So therefore this is equal to 41 over 169. So get rid of that from there. Okay, so this is exactly that. That's the probability of D complement intersection T. Okay, 0.049 minus 0.05p divided by the probability of all the T's. Okay, all the outcomes which involve T, which is this plus that, which we just are told actually that it's equal to 0.169. So we can just use that. And now we can solve this equation. If I multiply both sides by 169, that's going to cancel. And 169 over 0.169 is 1,000. Let's just make sure of that. 169 divided by 0.169. That gives us 1,000. So if I multiply by this both sides, this will be 1,000 times 0.049 minus 0.05p equals 41. So there, the small place moves 3 spaces. That's 49 minus, and that's going to be 50p is equal to 41. So I can say 49 minus 41 is 8 equals 50 times p. So I can say p is equal to 8 over 50. So you have 8 divided by 50, which gives you 4 over 25, which is 0.16. So we can say P is equal to 0.16. So there's the answer to part, well, we found P. That's part B. We found P. Now we've got to find Q. And I can go back to this equation that we formed here to find Q. Okay, so let's go back to that equation and find Q. I'll do that on the next page. Okay, so let me just take that information with me. So we've got this information. Let's take the whole lot of it together. Okay, and put it over here somewhere. So we know this information, and we also know that P is equal to 0.16 that we just found. Okay, so we can use this information to find Q, because now the only thing that we don't know here is Q. So we have 0.16 times Q plus, let's add these together, 0.0192 plus 0.049. That gives us 0.0682. And you got minus 0.05 times P, which is, again, we know that 0.16 equals 0.169. Okay, so we have 0.16 Q plus, now we found what this is. Take away from this 0.05 multiplied by 0.16. That gives us 0.602. 0.602, and that's equal to 0.169. So now we can subtract. 1 second, what did I do there? Let's just make sure I've got this right. 0.0682 minus 0.05 multiplied by 0.16. That gives us 0.062. So you've got to be very careful here. Be very careful in these questions. That are supposed to be 0.0602. Okay, and that would have messed up my whole question. Okay, so now I can say that 0.16Q is equal to, if I subtract that from both sides, I have 0.169 minus my last answer. That gives me 0.1088. 0.1088. So Q is going to be 0.1088 divided by 0.16. So Q is equal to, divided by 0.16. That gives you 17 over 25, which is 0.68. So Q is equal to 0.68. So there's the answer for Q. And we said that P was equal to 0.16 from the last question, from the first part on the other page. So there we have found the values of P and Q using those pieces of information that we were asked to use in solving this problem. Now we've got to go on to part C. Now, part C says a doctor is about to see a person who she knows does not have type B of the disease, but they do have a positive test result. So the doctor has some information about this person, okay, previous to seeing the person. So they have some given information, and with that information known, we've got to find the probability that the person has type A of the disease. So let's first of all fill in some of these values that we now know. So I know this is now 0.16. So here I have 0.16. I can get rid of this. And here this is going to be 0.68. So now I can work out what this is, because this is 0.98 minus 0.16. So 0.98 minus 0.16. That's going to give you 0.82, I think. Yeah, 0.82. So this is now, we can write as 0.82. And I know that this is 1 minus 0.68. So this is going to be 0.32. Right, so we know how some of this information. And as we mentioned, this is type A disease, type A positive, type A negative, type B positive test result, type B negative test result, no disease, positive test result, and no disease, negative test result. Those were the outcomes that we saw before. Now, in this case, the doctor is about to see a person she knows does not have type B. So we can get rid of all of this. All right? They don't have type B. So in this case, doesn't have to consider these at all. None of these will be in our outcomes. No type B. And they do have a positive test result. Okay, so that means we're only considering the positive test results, but excluding the one with B in it. So we're considering this and this outcome. These are the only outcomes that she's going to be looking at. Okay, she's not going to be worried about any of these others. Why? Because they don't have type B and they don't have negative test results. So you can get rid of all of these outcomes. The only ones we need to consider are these two. Okay, 0.68, 0.16 times 0.68. Write it like that. So that's 0.16 multiplied by 0.68, and this is 0.82 multiplied by 0.05. Those are the outcomes that she has to look at. Those are the sample space now. Only those two. It's limited to those two. We got rid of all of the other outcomes. Why? Because type B is ruled out and negative test results are ruled out. She knows that the person has a positive test result and they don't have type B. So those are the only two things she's going to consider. And you've got to find the probability that this person has type A. Okay, so having type A under these conditions would mean this probability, but the sample space is not the whole thing. It's only from these two added together. So the answer to this question will be the probability of having a positive test result from these, from what's left, is 0.16 times 0.68. And the sample space, the only outcomes she's going to be considering in total are these two outcomes, which is 0.16 times 0.68 plus 0.82 times 0.05. That's a probability that the person has type A, given that they don't have type B and also they have a positive test result. Yeah, that's basically what this is. So it's a conditional probability, and the easiest way to think about it, rather than using the formula way, because it's a bit more kind of like involved here, you've got different things going on, is to think about conditional probability in the way that I was trying to explain earlier, that you just consider what the sample space is, which is basically positive test result excluding B. So that's the total sample space. That's what's given that they don't have type B, and also given that the test result is positive. That's the only outcomes you can consider. That's going to be your denominator. That's your sample space. And the only one out of these where they have a positive test result, they have type A, is this particular outcome. So it's this divided by the sum of those two. Okay, I hope that was clear. All right, so now we can work out what that is. We can just stick that in our calculator. Fraction 0.16 multiplied by 0.68 divided by the same thing, 0.16 times 0.68, but then add the other outcome, which was 0.82 times 0.05. Make sure that's the times and the plus. Good. And that will give us our answer, which is 0.7263 goes on, 0.7263 goes on like that. So we should answer to 3SF. 0.726 is the probability that the person has type A of the disease, given this condition that the doctor knows already that the person doesn't have type B, and also that they do have a positive test result. Then it says, state giving a reason whether or not the doctor will find the test useful. Well, of course, the doctor's going to find it useful because, let's put this as part 2. Okay, if the doctor, if she had no previous information, she didn't know this information, that the person doesn't have type B and their test is positive, then the probability of type A is 0.16. Okay, that's the probability of having type A when she doesn't know any other previous information. Okay, but with this information, okay, known beforehand, the probability of type A given that information is equal to 0.726. So we can see that there's a higher probability that the person have the disease. So it's going to be useful for her to know that. A higher probability of the disease, therefore it's useful information. It's useful information for the doctor. It helps to, give her a better idea of whether the person has the disease or not. Okay, so there we have question number 3, part C. I hope that was clear. You have to have a good understanding of conditional probability here without always referring to the formula. It's very good to understand what its basis is. Okay, it's where you're limiting the sample space and you're taking only what fits from that sample space. Okay, so that kind of restricts the probability to a smaller kind of set of values. All right, so there's the answer. Other questions from this particular paper, June 2019, International A-Level S1, can be found in the link that will appear at the end of the video in this region over here. You'll have a link here taking you to questions dealing with probability from S1, and you can subscribe to the channel by clicking on this link. Thank you for watching and see you soon.